Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cashfly at CACHEFLY.com. This is Triangulation, episode 318, recorded Friday, October 20th, 2017. Philippe Kahn. Triangulation is brought to you by Eddie Bauer. This winter, don't let the cold hold you back from getting outdoors. Eddie Bauer's new Evertherm down jacket is unlike any other. No quilting, no cold spots. This is down. Available exclusively at Eddie Bauer stores or go to eddiebauer.com/Evertherm. Eddie Bauer. Live your adventure. It's time for Triangulation. I might add the Webby award-winning Triangulation. We just got our spring.
You know, that's usually mattress companies put these.
It looks like a mattress spring, doesn't it?
Yeah.
You cover that in fabric, you can sleep on it. If you were.
That's right. That's their patent. They put 20 of those or whatever in coils in the things, and then they make a mattress, and they claim that's better for your back. It isn't.
Ladies and gentlemen, I am so thrilled this week to be talking to a legend in Silicon Valley. One of the greats, Philippe Kahn, is our guest. And there's no way in an hour-long show I could give you his entire resume. I first became aware of you, Philippe, when for $49.95 I could buy a Pascal compiler that was 20 times faster than anything I'd ever seen before. Of course, we're talking Turbo Pascal. That was in the early 80s. But you may not know, but many of Philippe's technologies are in your life. If you use a smartphone and a camera, you could thank this guy here. If you have a Fitbit or an Apple Watch that measures your steps and your sleep, you can thank this guy right here. Philippe is an inventor, a legend in the business, and I'm thrilled to welcome you to Triangulation. Thanks, Philippe.
Thanks. I'm much better at inventing and technology than at making money, and I'm happy about that because I made enough to be happy, and I love building technologies and new things. So I kind of find my right spot there.
It's interesting. So you studied Pascal with the inventor of Pascal. How did Borland's Turbo Pascal come about?
Oh, well, so that was an interesting project. So first I came to America.
And then, by the way, immigrants, they get the job done, to quote Hamilton. You came to America without a green card.
I wasn't an immigrant. That's inaccurate.
Okay.
I was, to be accurate, I was an illegal immigrant.
Yeah, there you go.
I was illegal for 5 years in this country.
No green card.
No green card. I was on a tourist visa. So I hope someone's not going to kick me out.
A long expired tourist visa by the end of 5 years.
It was, yeah. Well, I'm a U.S. citizen now. But anyway, so yes, I came as a tourist, and I started a consulting company at the time called MIT Market in Time, because I realized that when I came here, I didn't know anybody, and I was a technical guy. So I started going, okay, I need to find work with people who need what I can do. So I started doing consulting, and I did consulting for Osborne. I actually worked on the operating system for the Osborne portable computer and stuff like that.
Now, that was DOS, right? But it had some custom...
No, that was not DOS. That was its own operating system.
It was? Oh, I thought it was... Because it came with WordStar and all these DOS programs, but it was its own OS.
Yeah, and so it well, you know, it wasn't Microsoft DOS. It was a disk operating system. Yes.
Yes, but not MS-DOS.
MS-DOS or PC-DOS. Microsoft had nothing to do with it.
And it wasn't CP/M.
No. Well, yeah, actually it was. It was a variation of CP/M.
Oh, okay.
The disk operating system varied of CPM, control program for microcomputers, something like that. That's what CPM stood, if I remember well. It's been a long time. And so everything was done in assembler language at the time, and I was pretty good at it. So that allowed me to make a living here. And get started and with my company. Unfortunately, my biggest customer was Adam Osborne, but unfortunately he went out of business and never paid the rest of my bills.
Oh no.
And so that's part of the storms we're talking about, what happens in business sometimes, you know.
Yeah.
So I had to, one thing against another, et cetera, et cetera. And so at the time, we needed to build. To build software, you needed tools, and there were two worlds that were coexisting. One was the CPM world, as you said, and the other one was the new PC DOS world, where that both were. One was kind of 8-bit, the other one was 16-bit. That was starting like that, and we needed tools, and so I needed a Pascal compiler, and so I licensed the actual core of a compiler from a company in Denmark called Polydata, and then I built a front end to it, which was really the key because everything was a command line interpreter, and at the time that was very difficult with small amounts of memory. You couldn't run simultaneously an editor in memory and a compiler and all that. Everything was very tedious because you had to fit everything in 64 kilobytes of memory, and so what we need to do is create an integrated system that ran in 60. So that's really what my contribution was to create an interactive, ultra-fast system that could actually do program, compile, debug in a very rapid cycle and allow people to build programs. And that was the success of Turbo Pascal.
Was huge. That in $49.95.
Well, that's an interesting point. I think price was a decision we made because in many ways we didn't have another choice. We didn't have distribution. We didn't have a company. We didn't have anything. So I asked Jerry Pournelle at the time, who I met. I was a big fan of his science fiction. I asked, what would you do? And he said, you should sell a mail order. And then I realized we studied mail orders. It says, okay, well, if we're going to do that, it has to be cheap. But the compiler itself, the pricing, the at the same price, you would have still used our program. If you could only buy it for $6.95, you would use our program. But that was a success of Turbo Pascal. Regardless of price, it was the best product. And then it was 1/10 of the price of the others, and you could get it direct. Right. And that was that created a fantastic opportunity. And so that started this company called Borland, and we followed up with actually what became the most successful product, more successful than
let me guess.
Pascal,
Sidekick.
Exactly.
The first terminate and stay resident program, man, that thing, you could multitask.
Yeah, but my concern when we say today, terminate and stay resident, my concern is people think of Trump.
That's terminate and stay president. That's a different.
That's right. I want to make sure we're really clear about it.
I'll just say TSR from now on.
Right. So the whole idea was that you had this little program that was always there, that was your calendar, your notepad, your address book, your dialer, your ASCII table, your whatever. And with a stroke of a key, boom, it would pop up because we didn't have any multitasking operating systems at the time. We didn't have Windows. So it was the first windowed interface system, truly, on a PC.
Oh, yeah.
It was text Windows, but it was Windows.
It was mind-boggling. You're sitting in a DOS prompt, and you could pop up your calendar.
That's right.
You could take notes.
Take notes, and if there was a phone number there, it would recognize the phone number, and it would actually dial the phone number through your modem if you wanted. A lot of salespeople started using it as as a great way to, and it was a really handy program. We sold it also pretty much for $49.95. It was a very big success, so millions of units. I mean, it sold 5 times as much as Turbo Pascal, and it really made the company. And from there on, Borland became successful, did IPOs and all that.
Why did, given that your reluctance to take investors, why did you go public?
That's a good question.
In hindsight, maybe you wouldn't have. In the long run, it cost you the company, didn't it?
Well, there's a couple of things. I didn't know anything about business, so I'm a technical guy. I'm a mathematician. I'm not a business person. I didn't know anything about business. The biggest business I had ever seen in my life was my grandfather's cabinet shop. Right. So and the life of musicians who get paid at the end of the, my mom, when she plays her violin in the quintet of the Hot Club de France or something like that, she would get her $50, whatever the equivalent, at the end of the night, and that's how the business was conducted, right? If you didn't get paid, someone didn't pay her, she wouldn't come back the next day. So it was so that was my experience with business. So I had a couple of, what happens when you become successful, you accumulate a bunch of people who have great ideas for you. Yep. So they recommended going public, and I went, why not? And so we did, and wow, that was a headache for me, because being the CEO of a public company is a very different life, and that's not really what I enjoy doing. I enjoy building teams and building technology and doing that, as opposed to running this bigger business with offices everywhere and all that. But we were successful for quite a while, and did a bunch of things until we were less successful, because of course we were a threat to Microsoft and these guys, and we were in a head-to-head collision with them. They
sued you over Quattro Pro, right?
Actually, it was
Lotus sued you. That's right. Yeah.
Lotus sued us because they couldn't compete with in the marketplace with our spreadsheet, so they claimed that our spreadsheet copied, and we said no, we did not copy, and they refused to settle, and so that lawsuit lasted for 7 years.
Oh my God.
We ended up winning in the Supreme Court, and it's a very seminal case. That's still one of the most important IP cases today, which basically it talks about the difference between copyright and patent law, and says that functionality cannot be copyrighted. Exactly like the
Was
chord.
it the slash key? Was it over the slash key? Was that one of the?
No, it was about the orders of the commands and menus.
Okay.
They were claiming that you
copied their menu order.
Copy. For example, if I look at my edit. Menu here is that copy, paste, delete, select all.
Right.
They would copy that you couldn't use that. In other words, the argument they were trying to make is that every car manufacturer should have a different function for the 3 pedals on the floor. Everybody should crash.
Right.
So that's the bottom line is, no, that's not the case. That's not copyrightable. That's functional. And if you want to protect functionality, then you use patents. If you want the right to copy or deny the right to copy, then you have to have something that is copyrightable, and it's not something as obvious as the order in which the words appear in a menu structure.
It's so exciting to talk to you, because I loved Quattro Pro. I loved Sidekick. I loved Turbo Pascal, and I mean, Philippe Kahn is our guest. He is, I want to say you're an inventor. And to this day, we are all using 2 of his key inventions right now, this very moment. I want to talk about that in just a second. Can we take a little break, Philippe? Just to do a commercial, just a 60-second break. But you might be interested in this. This is Eddie Bauer is our sponsor, and this is the new Eddie Bauer beautiful Evertherm down jacket. You look at this jacket, it looks like a pullover. It's very thin, it's very light. There's no puffy quilted. You don't look like the Michelin Man. This goes, but this thin down, 30G thin down insulation goes down to minus 15 degrees. Minus 15. All of a sudden, you can ski, you can climb, you can hike, and be comfortable and still be very warm. Snow hiking Minnesota, no problem. Ice climbing in Colorado, of course. Snowshoe trip through New Hampshire in the White Mountains. Eddie Bauer's Evertherm down jacket. It's not down clusters. It's down fabric. So there's no migration. There's no balling up, no quilting, no cold spots. In fact, if you look at the infrared camera picture of this, compare this to a puffy down jacket, you'll see it's completely even. It holds heat better than traditional down to minus 50. There it is, minus 15 degrees. It's perfect. And it's slim. It's ultralight. The men's extra large that I've got here is 11.36 ounces. And there's great arm mobility for if you want to. It's wind resistant. If you want to get outside, storm repel DWR technology means it's water resistant too, for men and for women. Of course, they test it out as all Eddie Bauer products with their world-class guides on Mount Everest and Kilimanjaro and the Grand Tetons. Live your adventure. The new Evertherm down jacket from Eddie Bauer. Available exclusively at Eddie Bauer stores or online at eddiebauer.com/Evertherm. I'm an Eddie Bauer guy. This sweater I'm wearing is Eddie Bauer. I love it. I've loved them my whole life. eddiebauer.com/Evertherm. Here comes winter, but there's no need to fear it. Love that Evertherm. Our guest is one of the most important people in the history of Silicon Valley. And unlike so many people who were there at the very beginning, he's still very active, and you're probably bored to tears. But 20 years ago, you did something really important that changed everybody's life, and it was at the birth of your daughter, who'd now be 20 years old, right?
She is 20 years old. She's a student at NYU, and she's a great kid. She is 20 years old.
Isn't that cool? That's so cool.
And she's it's a very simple story, and it's really a lot of so-called inventions happen that way. There's always a kind of a catalyst moment, and so what happened is that I was working for about a year after we sold a company to Motorola, company that did the first
Starfish
credit card size, Starfish credit card size organizer, and stuff like that. So that was acquired by Motorola. They wanted to integrate that into their phones, and so we actually I actually thought that with the web, it was 1997, 1996, 96. The web was, 3 years old, really. There was really no easy way to intelligently share media. Basically, people would send media via email attachments and stuff like that. So I built a server that was able to take an attachment of a picture, store it, and then send notifications to a whole bunch of people in an email list that there was an attachment, a picture that they with so the notification had a callback URL to that picture, so that if people said, "Hey, Philippe has a new picture that you could take a look at," and so you didn't need to send 2,000 pictures to people who you wanted. You just sent a notification. The server sent a notification with URL coming back, and then if you click that, then you saw the picture, as opposed to, brute force sending 2,000 pictures. That's exactly how Instagram or Facebook and all these guys work today, right? So we're talking about that thing. So I had been working on that server for quite a while, and then I was working on what we'd call today the edge device. The device that would actually create the content, which had to be some form of a combination of a digital camera and some kind of wireless system if I wanted to be able to do that anywhere, anytime. Wireless systems were limited at the time because it was 1200 baud analog phones, really, StarTAC phone. And the first successful digital camera with the Casio QV10 or whatever it is, I think the bandwidth in this house is going down because somebody is doing stuff with the bandwidth.
You got a teenager in BitTorrent?
You're seeing the quality go down.
It looks okay
right?
at this end.
Okay, good.
Yeah, it looks okay. Looks better than that very first picture of your newborn daughter in June 11th, 1997. This is the invention.
Well, that was
Look at that. That's the first camera phone picture. Wow. Look at that.
Yeah. So what? So anyway, so that was 240 by 320 was a quarter VGA resolution. That's all the Casio camera could do at the time. So what you have there is the best resolution we had at the time, and that picture was taken and shared instantly with 2,000 people.
You had a StarTAC phone, a Motorola flip phone.
Yeah, a Casio.
And the Casio camera.
Were
they connected? Well. And by the way, your wife's in labor. And actually, I'm sympathetic because when my daughter was born 25 years ago, I used HyperCard. I was busy writing a HyperCard contraction timer because as the father, you got nothing to do. And all you could do is like grit your teeth. So I understand the story is that I hear that you ran down to the car to get all this stuff while your wife's in labor.
There's a movie that's been made about that.
Is there really?
Yeah, you should see it. It became viral. It actually got a lot of downloads.
I'll look for it.
It's a 3-minute movie. We didn't make it. It was made by someone. It's extremely well made. They actually hired actors that kind of look like myself and my wife hysterical. And everybody else. And it's a high production value thing. And they did a really good job at. I think it's on Vimeo.
Okay, I'll look for it.
I can send you a link.
I'm sure I can. I could probably Google it. That's awesome.
I'm sure.
What does your daughter think about that? I mean, that's.
Oh, she doesn't.
She doesn't. She Snapchats and Instagrams and tweets and doesn't realize that all of that.
No. She does. She does, but she doesn't want to be known.
I don't blame her.
She wants to be. She wants to be known for what she does. So I'll
what does she do? She's at NYU. Oh, there it is. There's the 1997 Birth of the Camera Phone, Conscious Minds on Vimeo. If you want to, is it pretty accurate, Philippe?
It's unbelievably accurate. We didn't do anything. These guys took all the interviews and everything they could find, and they made this movie. And it's got great. I
love it.
Are you playing it right now?
Yeah. There's the young Philippe Kahn. There's Sonia.
Yeah, the sound.
Pregnant.
Is the sound there?
Yeah,
the sound is good.
We're just not playing all the sound just because we don't want to override your. I'm more interested in what you have to say, but we'll leave this as an exercise for viewers.
The sound is really good.
Okay, let's listen for a little bit then.
Honey.
Oh.
Honey.
Did you grab your phone?
Phone.
This is all accurate.
He's got his StarTAC. He's looking at his server, and he's thinking.
It's one of the few occurrences where you have a chance to speed and not be stopped.
That's right. Or if you are stopped, you have a good
Can you please
excuse.
slow down?
This is absolutely true. We got stopped.
You did get stopped?
License and registration, please.
So I explained to the officer that we were going to labor. The officer was funny. He said, I heard that line before.
Yeah, but if you look at your wife, it's pretty obvious.
This is 1997. The maternity doesn't have Wi-Fi, doesn't exist yet. If I wanted to share pictures instantly,
they went through the room.
That's the same room?
Yeah. They actually did their homework.
That's amazing.
How's it going?
Don't have the right cable.
Do you have your soldering iron?
Do you have your soldering iron?
And basically ripped up the whole speakerphone from the car.
Philippe, this is awesome. This is amazing.
This is exactly how it happened. These guys they went and interviewed the personnel at the maternity and their OBGYN and
wow. What did the doctors and nurses think? Were they
Oh,
desk that was next
the
to
surgeon.
the
She had a
C-section
C-section. The
operating
surgeon
table.
loved it.
Had
He's a
long
geek. He's a
wire
friend.
Oh, that's
He
neat.
was more interested in what I was doing than in the baby.
Poor Sonia.
to the surgeon. That was my kitchen.
But I guess your wife's used to it. She actually, what I love about the story is that she helped you found your companies and helped run them with you.
Oh, she does that with new companies. She's very key. I couldn't do it. I mean, she's the operational person.
And there's the
She's my-
picture. Boom.
and
That's it.
that's how it happened, and went to a lot of people.
Now, did you
And-
think at the time this is a business?
No, well, actually, it took responses from. I didn't think about it as business. I thought about sharing, with friends and family. I mean, Sonia was born in South Korea. I was born in Europe, and so we have people spread all over the world. So we're able to share the good news instantly. Point, shoot, and share instantly. That's what it was about, and that was what. It was necessity created function.
Right.
We did that. But you know what? Then suddenly a lot of people went back, said, how did you do that? Because they could see we're taking these pictures in real time.
Yeah.
And then after a few times, we go, oh, people really want this. We better, this is our business. This is our next business.
You shared a web server link with your friends and family that had a folder of pictures on it, and they could watch in real time as those pictures arrived and showed up on their screen. They could see it. Is that how it worked? I mean, because they didn't have a phone you could send it to.
Almost, no, because it was 1997. A lot of people didn't have cell phones. So some of them did. And so there was SMS, instant messaging didn't exist yet.
Right.
That's not 20 years ago, right?
Right.
And so what we shared is a notification that there was a new picture with a callback URL.
Got it.
And so that was it was so efficient. You couldn't share a folder or stuff like that over
Right.
networks and stuff like that. That didn't exist at the time yet. So so what we were able to do is basically it's the blueprint for Facebook or
Right.
Instagram. And this is why Facebook and Instagram were never able or even any of those systems weren't able to get patents, is because our system was clear prior art to all of this. It was the first. So we didn't patent that aspect of the system, but what we patented is elements of the hardware and the software. And so we got the first, camera phone patents, which are now owned by people like Google, who, patents get sold and then sold again. It's like paintings for painters, Suddenly you see your paintings hanging on some wall, someone who paid for it. And the patents are the same way. You sell the company, and then the buyer of the company sells this patent to these people, and they end up somewhere else. But it's kind of a fun thing.
It must make you feel good, though, when you see everybody's using camera phones. These aren't phones anymore. They're internet connected devices with a camera. I mean,
that's right.
You before anybody saw the technology that's one of the most important technologies of the 21st century, and you saw it in the 20th century.
Well, it's instantly. If you look at the story, IEEE wrote a story about this for the 20 years of the thing of the history of the camera phone, and IEEE wrote a story, and she went and talked to Bob Parks, who's the guy who wrote the story at the time in Wired magazine, and she asked Bob, what did you see? What did Philippe actually tell you that? Because, it's very easy for people to remake history and say,
right.
Oh, we thought about citizen journalism, we thought about telemedicine and all that. And Bob, in that article, says, I was amazed because I was interviewing and he was talking about all these things that we could do with this device back in 1999, and it's all happened. And at the time, I said, "Yeah, this is never going to happen. This is kind of science fiction." And we really saw citizen journalism happen. We saw telemedicine happen. We saw barcode reading happen. We saw scanning of documents happen. We really saw this as suddenly imaging and wireless and instant sharing married together could do fantastic things. and in many ways, if you look at the so-called progress of the latest iPhone, the iPhone 10, it actually uses the camera for authentication by detecting your face.
Right.
And so now suddenly the camera is also part of, it's not just a fingerprint scanner. Now the camera is important because it knows about you. So we felt that the camera was the eyes of the internet, and eyes are a very important sense. I mean, in what we do, and so that was kind of a fun thing, and the company was very successful.
LightSurf was the company you founded around this technology.
We ended up being acquired by
VeriSign,
a company called VeriSign, and they sold a lot of the assets to Nokia and people like that. They did a few things, and it was very successful for us. And we started, when we realized that sensing was going to be so important, and we had put basically a imaging sensor in every phone. That's what LightSurf did. With Fullpower, we decided to put all sorts of sensors in every phone and try to understand what we can do with connected objects and sensors.
We're going to the fourth act, and the fourth act is just as important as acts 1, 2, and 3. We're now talking about Fullpower. And for years, my favorite GPS program was something called MotionX. That was the greatest GPS program. It was really great.
It's still there. It's still there, but of course, there's a lot of
there's some competition from Google and Apple now. But
well, it's all free, but it's still MotionX GPS, according to people who use it,
love it.
It's the best. It's a more complete, but of course, competing with free is difficult. So, the whole idea initially was to prove that our technology worked and that we could build an accurate system. And
so it wasn't just GPS, because Fullpower, I mean, if you wear a Fitbit or an Apple Watch, the technologies that are in those, that's your accelerometers. Those are your sensors, right?
Well, we were the first ones to do that back in our first patents date back to 2004, have to do with accelerometers and in devices, et cetera. And we that's before Fitbit or anybody like that existed. We established a relationship with Nike. Nike became a customer, and that was our real first strategic customer at Fullpower. That's our website, I guess, with Fullpower.
Yep.
And you probably see the different if you go down that.
Well, I see the next generation, which is IoT
some of the things that we do. This is what we do. So we do. If you look at the top, we connected objects like drones and beds and appliances. We do medical devices. We also do sleep monitoring. We built a smart bed for the largest mattress company on the planet called Simmons Serta, which has a bunch of brands. Then we also are present in the connected office, and Nike is one of our long-term customers. So that's what we do. So we build technology. We're business to business. Right? We build technology for people who go and market. We don't have marketing and sales. We're really good at building a platform that allows for creating AI-powered cloud-based IoT solutions, and we focused on difficult problems where machine learning and deep learning are essential to solving the problems and continually improving the algorithmics of a solution. So it's a great company. We love it because we're basically like a super university with mathematicians, bioinformaticians, nuclear physicists, and all that. That's the team we have, and we're trying to figure out how to create new solutions that troubleshoot themselves, that keep themselves up and running, and that keep on improving automatically all the time with as little human intervention as possible, yet solve very complex problems like analyzing people's sleep, like trying to understand someone's blood glucose management, or
you're working on that. That is the holy grail, isn't it?
Well, it is the holy grail. it's a holy grail in the following way: is that monitoring things like blood glucose for about normal ranges, there's no difficulty, great difficulty. We do that all the time. The challenge is the extremes, which is very low, very high, because that's life-threatening, and no non-invasive system is really able to do that reliably today. And that's and billions of dollars have been spent. There, we work with some big farm companies.
So you're working on stuff like that?
We work on the artificial intelligence behind things like that, to actually try to solve the problem by multiple approaches, and really having something that is useful. Because if someone is diabetic and say a type 1 diabetic person, and you could tell him, well, you're fine, your blood glucose is okay, it's between 80 and say 300, and it's okay, nothing bad's going to happen. But if you're not capable of telling him instantly and notifying instantly, alert, if the blood glucose goes up to 450 or goes down to 60 or 55, then you got a problem, because someone's going to die on you or is at risk to getting into some diabetically induced coma.
Are you using Lisp for this stuff?
I personally, I'm a Lisp guy. So unlike people thought that, I was a Pascal guy and all that. Yeah, I was in some ways, but I'm a Lisp person. So,
well, you're a mathematician, so Lisp makes sense to you because it's essentially a mathematical model, right?
Well, yeah. I mean, it's people. I use a dialect of Lisp for everything I do. I use Scheme.
You use Scheme, yeah.
Scheme, which is a dialect of Lisp that's implemented on most devices nowadays, and that's what I do. I model everything, and the guys at the office can tell you that. But most of the work now is done either in C or Python. Yeah. And Python is a very popular language, and I think it's kind of won over Java, etc. So,
but I think it's interesting that all these functional languages are moving more. I mean, all these imperative languages are moving more and more towards functional languages. You might win in the long run, Philippe.
I think that we are object orientation is something that we pioneered. I pioneered many years ago. And I think that object computing is very important, and Python has a very good object implementation. It's well done, and it works quite well. Python is also a recursive language, unlike a language like BASIC or stuff like that. That's pretty useless for that. And so recursion is, I think, it's an important part of thinking in AI, really, and because thinking recursively is really a key way to solve intelligence simulation challenges. And functional programming is very important. The concept of functional programming is not supported by most languages, which is basically having a function as a variable and being able to treat everything that's what really Lisp is everything is the same. And I think that Python does a bit of that, and that's actually good. And so now it's a matter of people learning Python properly. So I'm sure somebody will do that.
I always, when people call me and smart kids call me, I say, get Dr. Racket and get HTDP, how to design programs, and learn it right, and then you can learn. Then you can learn C++. So,
oh, that's you mean Dr. Racket?
Dr. Racket's awesome.
Yeah, and actually, that book, the old that book, that MIT book, is actually one of the best books ever written, and actually, it's free online.
I know. I love it. That's the beauty of it. You could be a 12-year-old. You can get the book. You get the language, everything on any platform, and learn.
That's right. The only thing is that a lot of people are. Anyone who learns, Dr. Racket is a good example of a very good implementation of Scheme. So anyone who takes the time to learn something like that will develop great skills for problem solving, computer engineering, software engineering, anything. The problem is a lot of people are not willing to go through. There's a steep learning curve, especially in the beginning. If you want to pass the first, say, 4 or 5 chapters of that book or any, then there's a steep learning curve and people give up. I've seen that. I've seen that with kids. And, you know, the methodology to get over that, which a lot of people don't know, and that's used by most people. I know I use it. Apparently Einstein used to do the same thing, so it must have been okay. It's like when you read a science book, a technology book like that, what you do is you start reading it from page 1, and then everybody hits a wall at one time, whether it's a book on scheme programming or a book on quantum mechanics. When you hit that wall, you stop and you start the book again on page 1. And you do it again, and now you find that by the time you get to where you hit the wall, you get 10 pages more. And then you hit that wall and you start again.
This is good because I've read How to Design Programs. 5 times. I keep getting a little farther. Exactly right. I keep starting over a little farther.
That's the method. That's really the method to use that. Einstein used to do that with old books. I personally use that all the time, and it really is the way to do it. A lot of people say, "Oh, I hit a wall. I'll give up on that book." No, don't do that. It's a good book. Just give up on the wall, start from the beginning, and everything looks simple and trivial, and you're really happy, and next time you go a little further.
Yeah.
Well, that book, How to Design Programs, is a very dense book.
Yeah.
It's got a lot of information in it, and it's a fantastic book, but it's dense, and so that's the kind of book where it'll take you 2 years to read it. Yep. But if you go through that, you've learned a lot.
Philippe Kahn, it is, first of all, you just validated everything I believe in. I've bought every iteration of everything you've ever done. All of us have, but I mean, I'm going back to Turbo Pascal and Sidekick, the Starfish synchronization stuff, MotionX. The world would be a very different place without Philippe Kahn. And I don't know how many people realize that, but I hope a few more realize it.
You know, what we're doing right now, more importantly than MotionX, is we've been spending the last 10 years on understanding human sleep. And so that's a very difficult challenge.
Yes.
And because we spend a third of our life sleeping, but we don't know much. It's like the deep ocean. Only we know we don't remember, because that's part of the sleep experience. And a lot of the analysis that exists, called polysomnography, that you get when you get to a sleep specialist, is invasive in the way that, you know, they wire you in such a way that you're not measuring your actual sleep every day. You're measuring your disturbed sleep in a little office at a doctor. And then they prescribe you with a CPAP machine and say, okay, now for the rest of your life, you have to sleep with this crutch with you. And if you don't do that, you might have an accident. And what we're trying to is turn this around and says, well, let's find out what sleep's really, what happens in your environment. Let's not rely on myths like the myth of the 8-hour uninterrupted night of sleep. You know, when is it from an evolutionary standpoint that anyone said that you had to sleep 8 hours? No one ever did that. And in fact, you know, when is it that people are supposed to sleep in a perfectly dark, perfectly quiet environment? Humans have evolved sleeping in communal bedrooms where 5, 6, 10 people would sleep at the same time. There was someone standing guard because the saber-toothed tiger wanted to get into the cave to get their dinner during night. Some of the group there was hunting at night because that's where the preferred time to hunt. So obviously they worked a graveyard shift. They were hunters and they sleep during the day. Most people had interrupted sleep. Where is that idea of the myth of the 8-hour?
How do you sleep, Philippe? Do you do the dual sleep thing where you sleep 4 hours, awake a few hours, and go back to sleep? Or
that's what I do.
Yeah,
I sleep in 2 or 3 shifts. Learned that sailing across oceans.
Oh yeah, you have to. You have to stand watch.
You have to.
Yeah.
Well, that's exactly right. And so, especially when there's only 2 of you on the boat,
Yeah.
There's always one that has to be up.
Right.
And you never see each other when there's 2 of you up, because as soon as one is up, the other one goes to sleep. So
you're a polyphasic sleeper.
Well, that's true. So the way that works is that we sleep in our sleep. There are multiple cycles. They goes from you fall asleep, then you get into deeper sleep, then you come up, and then you get this phase called REM sleep, which is where you dream and you go back to a deeper sleep, etc. And you go through these cycles. Most people last 45 minutes to an hour and 30 minutes per cycle. And pretty much every day, if you have to sleep for at least 4 of these cycles, and at most 6 of these cycles, to be rested and to recoup and rebuild yourself. Different phases of sleep are meant to rebuild different parts of you. REM, the dreaming part is rebuilding your psyche. Deep sleep is rebuilding your body. I mean, so we're very well engineered by Mr. Darwin or people like that, God, whoever it is, and so we're engineered in a way that we're made to rebuild during the night. But so if you have more than 6 cycles, it shows that people start having nightmares and all that because it's too much.
Interesting.
And if you have too little, you're not right. Unlike what people think, American sleepers sleep more than anybody else on the planet. We have recorded over 100 million nights of sleep, actually 500 million nights of sleep. Wow. We found that the average American spends about 8 hours in their bedroom, a third of their lives, but sleeps about 6 hours and 30 minutes, a little more on weekends, we can even see during weekdays on the average, who sleeps most, etc. But my point is that in Europe, they sleep less, and in Asia, they sleep even less.
Huh.
And so, we're doing pretty well in some ways in sleep, but we are traumatized by the myth that if we have interrupted sleep, something's wrong with us, and that's not correct. And I think that respiratory events during the night can be monitored. Some people obviously need CPAP machines, but CPAP machines are prescribed to so many people now. It's such a big industry and profitable industry that we think that they're overprescribed like everything else. And, because it's a business opportunity for people, whether it's your local physician who gets a cut on every machine. And now, of course, the machines come with something that follows you and that monitors you, where you have to pay a subscription and all that. So it's a little bit like people with diabetes and taking insulin. Once they do that, the insulin makers think that they're going to sell you insulin until you die. Yeah. And so it's almost a business model. And I think that's not right. I think that we can do better for Mrs. and Mr. Everyone by giving them the opportunity to monitor their own sleep, understand it better, and then decide what they want to do, as opposed to be told this is what you should do because this is the truth. And the knowledge that the medical community has on sleep is fairly limited. The science that we derive out of 100 millions of nights of sleep is extraordinary in the following way. For example, my sleep gets scored every night with our system. By the way, our system is sold by Beauty Rest, and it's on Amazon. You can buy it for probably $100.
Oh, so I don't have to get a Serta Simmons mattress. I could get something that I put under my mattress.
It works with every.
I'm buying it right now.
It works with every. No, I'll send you one.
No. Just tell me, what's the name of it?
It's called a Sleep Tracker.
Sleep Tracker, and this is kind of like the Motion X stuff that you created. The Jawbone Up. I had the Jawbone Up.
Yeah, it's
but
much
this
better.
is adapted for sleep tracking. And is there software that goes with it?
It's a complete IoT AI-based system that's cloud-based, that does your analysis for you, that compares. So, for example, you get a sleep score every day.
Yeah.
And so the sleep score, like say that you're in the 75th percentile, and then there's 25% of people just like you that have a better sleep score. So the AI system now tries to see what is it that these people do, how do they sleep, what is it that they do that we know about that lets them improve their sleep score over yours.
Do you think we know enough now about how sleep works and what is optimal that this can be tied with artificial intelligence to give me recommendations that are actually usable? You must.
Well, it's the opposite of what you just said. Of course, this is true what you say, but the science comes from the millions of people.
The observations you have.
Yeah. Because that is the data speak.
But how do you correlate it with success? I mean, you know how I sleep, but how do you know that that was beneficial and healthful? Are you questionnaires?
Well, a couple of things. First, how do you rate your sleep? And so through our machine learned and deep learning systems have derived a sleep scoring methodology that takes into account how long it takes you to fall asleep, how long you're actually sleeping versus how much time you spend in bed, how much deep sleep you get, how much light sleep you get, how much REM sleep you get, how disturbed your motion is during your sleep, how your respiration rate is during your sleep, how your heart rate is.
How do you can measure all that with something under my mattress?
Yes.
I don't have to wear something?
No, you don't have. It's completely non-invasive. And so
that's my problem with Apple Watch and the Jawbone and all that. I don't want to wear this while I'm sleeping.
No one likes to wear that.
Wouldn't it be better to have an EEG measuring brainwave activity, or is that not necessary?
That's not necessary, and that's really invasive. You know, the EEG things measuring brain activity. You know what I call that?
What?
It's the best contraception device.
It's not sexy. Not sexy.
Yeah. You have two. You have
neither is a CPAP machine.
Wearing these things, and I guarantee you that you will lower the birth rate.
All right, $100. I'm buying this. You convinced me. The Beauty Rest Sleep Tracker Monitor wearable free sleep tracker. You just put it under your mattress.
That's right.
I'm very interested in this, Philippe. We do know. I mean, it's everybody accepts now that sleep is really important to overall health, and we also, I think, a lot of us know it's not working. Whatever we're doing isn't working. I wake up every night, and I could easily be up for a couple hours and go back to sleep. In fact, the times I've done that, I felt very good.
What's wrong with that?
What's wrong with that? Except for family and friends, but other than
Newton did that.
Yeah.
Einstein did that.
Sure.
Mozart did that.
Sure.
Some pretty smart and talented people did that. In fact, if you look at the history of sleep, you'll find that in Shakespeare's plays, for example, people would get up in the middle of the night, go visit other people, and come back. So that was the mode. It was called first sleep and second sleep.
Right.
And that was the mode. Most babies were conceived not when people went to sleep because people were too tired at the time. It was too cold. Most baby was conceived in between first sleep and second sleep. So it's actually...
That's a good activity in between. Now I'm thinking I don't have to write a journal or read the newspaper. I could make a baby.
Or several.
No, I'm done.
So the real thing is really that one is let's have an open mind. You know, it's like diet. If you went there 30 years ago, 20 years ago, people would have said you should only eat pasta and carbs, get away from fat and protein. That's all bad for you. And what they realize now with that approach is they created the worst epidemic of diabetes ever with that
Yep.
approach. It's been
Yep.
horrible.
Yep.
And that was science. It wasn't science. It was a bunch of idiotic nutritionists who made this stuff up. The stuff about sleep is exactly the same thing. It's a bunch of people who said, "Oh, you have to sleep this. I'm a MD. I'm going to write a book and I'm going to get on television and tell people how they should sleep." The data doesn't show that. When we look at all the people that are sleeping and the millions of nights of sleep we record, the data doesn't show that. And when if you start using our system will compare you to people just like you, same biometrics, not necessarily age, but same kind of biometrics, et cetera. And we'll say, hey, people just like you sleep on the average 15 minutes less or 15 minutes more, or you wake, and then you have an idea how you're doing as opposed to some kind of you should be sleeping for 8 hours. And
See, this is really interesting because this is a really a larger story of big data and how a data-driven approach to this stuff can be very interesting. And I can see why you're interested in machine learning and artificial intelligence. And I think we're about to enter an era where things change a lot because of collecting data instead of just making stuff up.
Well, that's exactly it.
Yeah.
And I always tell people, I mean, that's my management rule for a lot of people. I say, listen, I don't want to have to make decisions and have opinions. I want the data to speak. So show me the data. Let's let the data make a decision. Now, if it's a matter of opinion, I'm the boss. We'll go with mine. But that's I don't want to do that. The most important part is to have the data, have the tools, the AI tool, the machine learning, the deep learning, et cetera, and actually have the data tell us what's going on. And sleep is fantastic for that because we're learning so much more and we know so much more than most sleep specialists that it's almost like laughable because we don't need to make up the science. The data shows us how do people sleep, how people sleep, and who's good, who's bad, who's rested, who's not rested. You'll see with the system if you use it that as your day goes by, you'll see as your night goes by, your heart rate go down, go back up, then go down, go back up. When your heart rate reaches its minimum, that's when you're rested. And naturally your body will want to wake up. And that has nothing to do with how long you slept. I mean, there's a little bit to do, but it's more how you recoup. And the quality of sleep. Yeah. And I tell you another side of things, which is people tell you, oh, you should sleep 8 hours. Well, people say, wait a minute, my sleep budget is 6.5 or 6 hours. I've got a job, I've got kids, I've got a dog, I've got Game of Thrones that I want to watch. I've got all these things that I need to do, right? So my budget for sleeping is that. So you can't tell people you should sleep 2 hours more. It's not going to happen. It isn't. It's like telling people, you're never going to eat, a piece of chocolate anymore. That's wrong. What you have to tell them is how to eat that piece of chocolate, when to eat it so it doesn't hurt them. But you can't tell them you can't eat a piece of chocolate anymore because that's not sustainable. I mean, for Mrs. and Mr. Everyone. Same thing is true. So the only solution is to say, okay, you've got a sleep budget of 6 hours. Then we need to help you be more efficient to improve the quality of sleep so that you feel like you slept 8 hours, but you did it in 6 hours. And that's really where the science, I think, and the opportunity is to help Mrs. and Mr. Everyone with what they got, not what, they will never get, like 8 hours uninterrupted sleep without the phone ringing or something.
I am so thrilled to meet you, Philippe Kahn. You've always been an important presence in my life and the life of technology. I thank you for all you have done. And I very much thank you for your time today. It's really been fantastic.
Well, it's great to meet you there. And I talk to a lot of people. You're aware of all of this, which, again, that's even more fantastic because who do you talk to about these things if they're not aware of it? So this is a fantastic program, and I really appreciate it. And I love that Eddie Bauer Dawn jacket. I'm going to go buy one.
Oh yeah, I know you like to be outside. This is
oh
it.
Yeah. I'm going to use it sailing. I'm going to see how. I'll report back.
Will you please? I'd love to get you back. And anytime you're up in Petaluma, please let us know. We'd love to have you in studio. It's a real pleasure to talk to you.
Same here.
Thank you,
Bye-bye
Philippe.
now.
Take care. Philippe Kahn, what more can I say? That is a real honor and a pleasure and a privilege. It's one of the reasons I love doing Triangulation. We rotate it now. You know, I do it with Megan and Jason and Father Robert. Each takes a week, and that gives us a nice variety, not only of hosts, but of topics, because they all have different interests. I hope you are watching the show. We now record it at a new time, as you may have noticed, Fridays, 3 p.m. Pacific, 6 p.m. Eastern, 2200 UTC. If you want to watch live, we love it. You can join us in the chat room at irc.twit.tv. Your comments, suggestions, questions are very much a big part of this show. It's called, it's a triangle. You're the third side of the triangle. Please join us. But if you can't watch live, don't worry. On demand, audio and video is always available of every show we do. You'll find this one at twit.tv/TRI, or just go to your favorite podcast app and subscribe. And we Stitcher, Slacker, Overcast, Pocket Casts, we're iTunes, we're everywhere. Just look for Triangulation, subscribe, because I tell you, this is one show you do not want to miss an episode. We've got some great shows coming up for you. Next week, we're going to talk about gallium nitride technology and how it's changing everything, including wireless charging, amplifiers, and ultimately CPUs. In a couple of weeks, we're going to speak to Andy Weir. He's, of course, the author of The Martian. His new book, Artemis, comes up November 14th. We've got an interview with him already in the can. It's a great book. It's a great interview. And it's just one more reason to make sure you tune in for Triangulation. We'll see you next time.